There's just one major reason why, even today, we've barely been able to carry out space missions to Mercury. Do you know what that reason is? Well, let me ask you something first. How many missions have we sent to Mars? Around 30. To Venus? Around 22. In fact, we've even sent missions to Pluto, the farthest dwarf planet in our solar system, and we've sent 2 spacecraft into interstellar space. But what about Mercury? Yes, you heard that right. Mercury is actually closer to Earth than both Venus and Mars in terms of minimum distance. Yet how many missions have we sent there? Well, friends, you're going to be shocked by the answer. This story begins on November 3, 1973 at 5:47 a.m. from Launch Complex 36B in Florida. NASA's Mariner 10 spacecraft was ready for its historic journey to Mercury. Every scientist had one question in mind. Would it actually make it to Mercury? Because this was the very first spacecraft that would attempt to reach Mercury using gravity assists without carrying enough fuel for the entire journey. Surprisingly, after some time, the scientists realized they had worried for nothing. The spacecraft successfully completed its long journey, but then something unexpected happened that almost made all their hard work seem pointless. During its final flyby, after running out of fuel, Mariner 10 ended up heading toward Mercury at nearly 5 times the speed of sound, eventually crashing into the planet's surface and being destroyed. Now, technically, its main objective was to capture photographs of Mercury and transmit them back to Earth, and it did exactly that. So why is the mission often considered only partially successful? Here's why. Space probes designed to photograph planets usually capture over 25,000 images. Mariner 10 managed to capture only about 2,700 photographs, and some of those were actually pictures of Venus. As it approached Mercury, the spacecraft encountered problems that almost no other planetary probe had ever experienced. Those problems continued until it exhausted its fuel, ultimately leading to its crash. So what makes Mercury so different? For starters, the sun's extreme heat, the sun's immense gravity, and Mercury's own reflected heat. Any spacecraft heading toward Mercury is influenced by 2 major gravitational forces: the gravity of the sun, the gravity of Mercury. Now think about it, which one is stronger? Obviously the sun's gravity. That means a spacecraft naturally wants to fall toward the sun rather than Mercury. This is one of the biggest challenges of sending missions there. Scientists eventually found a solution, but it required incredibly precise calculations. The answer was speed. A spacecraft has to travel at exactly the right velocity. If it approaches Mercury too slowly, the sun's gravity, or even Mercury's, will pull it in, causing it to crash. If it travels too fast, it'll simply fly past Mercury without collecting enough scientific data. Unfortunately, that's exactly what happened to Mariner 10. During its final flyby, intense solar radiation slightly altered its trajectory. That tiny deviation caused Mercury's gravity to capture the spacecraft, pulling it closer and closer until it finally slammed into the planet. Now you might be wondering, with so many challenges, why do we still want to study Mercury? Why did we launch another mission there in 2018? Before answering that, imagine watching a sunrise where the sun rises twice. That's exactly what can happen on Mercury. Even more astonishing, one single day on Mercury lasts as long as 2 years on Earth. In other words, your birthday would arrive twice during a single Mercury day. But why? Let's break it down. One Mercury day lasts 176 Earth days. That tells us Mercury rotates extremely slowly. Meanwhile, one Mercury year lasts only 88 Earth days, meaning Mercury orbits the Sun incredibly fast. So, one Mercury year equals 88 Earth days. 2 Mercury years equals 176 Earth days, which means one Mercury day equals 2 Mercury years. Essentially, one side of Mercury experiences nearly an entire year of daylight, followed by almost an entire year of darkness. But why does this happen? If you understand this, you'll be halfway toward understanding Einstein's general theory of relativity. Let's take a simple example. Our moon is tidally locked to Earth. Earth's gravity is so strong that the moon always keeps the same face pointed toward us. Mercury experiences something similar. The sun's gravitational influence is so powerful that it significantly slows Mercury's rotation. But why does Mercury still orbit the sun so quickly? That answer goes all the way back 4.5 billion years when our solar system was forming. As the giant cloud of gas and dust, the protoplanetary disk, collapsed under gravity, every forming planet inherited momentum. Think of a ballet dancer. When the dancer pulls in their arms, they spin faster. When they stretch their arms outward, they slow down. The same principle applied during the formation of the solar system. Material closer to the sun moved faster because of stronger gravitational acceleration, while objects farther away didn't receive the same boost. That's why planets closer to the sun orbit much faster than planets farther away. And that's exactly why Mercury completes 2 years in the time it takes to experience one full day. Scientists have already launched a mission to test these ideas more accurately. It's called BepiColombo. This mission will study Mercury's atmosphere, chemical composition, geology, and evolution. It also carries several advanced scientific instruments. One of them is the Italian Spring Accelerometer, an extremely sensitive instrument capable of measuring tiny distortions in space-time caused by Mercury's strong gravitational environment. This allows scientists to test Einstein's general theory of relativity with unprecedented precision. The mission will also help answer another mystery. Why is Mercury's magnetic field so weak? Mercury's metallic core makes up nearly 85% of the planet's volume, while Earth's core accounts for only about 20%. Yet Earth's magnetic field is much stronger. If scientists can solve this mystery, they may also understand why Mercury's magnetic field is significantly stronger near its northern hemisphere. Despite its challenges, Mariner 10 still made several groundbreaking achievements. It transmitted humanity's first high-resolution images of Venus, something earlier missions like Mariner 1 and Mariner 5 couldn't accomplish. It also proved that gravity assist could be used to travel across the solar system. So what exactly is a gravity assist? In simple terms, scientists use a planet's gravity like a giant slingshot. A spacecraft swings around a planet, gaining speed and changing direction without using much fuel. That's exactly what happened with Mariner 10. As it flew around Venus, scientists carefully adjusted its trajectory, allowing the spacecraft to gain enough speed to head toward Mercury. Then, on March 29, 1974, Mariner 10 reached Mercury and sent back humanity's very first close-up images of the planet. Today, the same gravity assist technique has helped send 2 spacecraft into interstellar space and enabled New Horizons to capture stunning images of Pluto. But one question still remains. Why does Mercury behave so strangely? In fact, Mercury isn't the only bizarre world in the universe. Astronomers have discovered planets with properties so unusual that they almost seem to challenge the laws of physics themselves. One of them is even larger than its own star. I've covered all of these fascinating worlds in another video where we explore the strangest planets ever discovered. If you enjoyed this video, don't forget to leave a like and press the notification bell so you never miss another upload. I'll see you next time. Until then, as always, stay curious, keep learning, and keep growing.